trig integral here, and this time we're doing one that's a little bit more complicated. We're doing the integral of secant to the 6th x over tan squared x dx. And in this case, we do have powers of secant and tangent, so this is kind of like one of those rules we were talking about before. However, the different part about this one is that it's in the form of a fraction and they're not as a product. That actually is not that important. It will work out the same. So what we want to do is we want to say, when we have even powers of secant, we want to convert all but 2 of them to tangents, leave a secant squared, because that is the derivative of tangent, and then we would have an easy substitution. So what we want to do is say this is secant squared x, secant to the 4th x over tan squared x. And secant to the 4th is secant squared squared, and secant squared is 1 plus tangent squared. So we get secant squared x. This would be 1 plus tan squared x squared all over tan squared x. So remember that secant squared is 1 plus tangent squared, so secant to the 4th is that squared. And now we're ready to do a substitution. We want to say that u is equal to tangent x, because then our du is secant squared x dx, and we have a secant squared there, so it'll cancel out perfectly. So when we do that substitution, the integral becomes, this secant squared will cancel out. What we have is 1 plus u squared squared over u squared du. And that's a much simpler integral to calculate. So what we need to do here is just expand the numerator and just divide each term by the u squared. So 1 plus u squared squared would expand to 1 plus 2 u squared plus u to the 4th by FOILing that out all over u squared. And if you divide each term by u squared, we get the integral of u to the negative 2 plus 2 plus u squared du. And those are all done by just power rule, simple antiderivatives. So this would be negative u to the negative 1 plus 2u plus u cubed over 3. And remember here that our u was tangent. So when we plug back in, we'll be done here. Tangent to the negative 1, in other words, the reciprocal of tangent, we can just write that as cotangent. So this is negative cotangent of x plus 2 tan of x plus, this would be tan cubed of x over 3 plus c. So in this case, we just are obeying the same rules in terms of powers of tangent and secant that you would do if it was a product. But just because it's a quotient, you might have extra things to do like this afterwards, but the rules are basically the same. So always look for a way to get the derivative of something else in the function, because as soon as that happens, substitution is going to make the integral really easy.